Alright, so in this problem, I have 2 to the power of x plus a to the power of x is equal to 10. So, I want to find the value of x here. So for my solution, I get 2 to the power of x plus a to the power of x is equal to 10. Now from here, a I can rewrite as 2 to the power of 3. So I get 2 to the power of x plus 2 to the power of 3 to the power of x is equal to 10. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of x plus 2 to the power of 3 to the power of x, that's the same thing as 2 to the power of 3x. And now this is equal to 10. Now, I can rewrite this as 2, plus sign, 2 to the power of x to the power of 3 is equal to 10. Now, I'm going to let 2 to the power of x equal to the variable y. So I get y plus y to the power of 3 is equal to 10. Now, if I subtract 10 on both sides, these two cancel out, and I get y to the power of 3 plus y minus 10 is equal to 0. Now, to actually solve this equation, we need to first start by finding one solution and then use that one solution to find the rest of the remaining solutions. And to find that first solution, what we actually have to do is just test in values, plug in values, and see if they're right. So I'm going to first start with y equals 1. If y equals 1, I get 1 to the power of 3 plus 1 minus 10. And this is equal to 2 minus 10, which is equal to negative 8, which is wrong. Now, if y is equal to 2, I get 2 to the power of 3 plus 2 minus 10. 2 to the power of 3 is 8, so I get 8 plus 2 minus 10, which is equal to 10 minus 10, which is equal to 0. So this is right, meaning y equals 2 is a solution to this. So this also means that I can divide y to the power of 3 plus y minus 10 with y minus 2, because 2 is a solution. If I plug in 2 and y minus 2, I get 0. So if I do this, I can find the remaining solutions. So the easiest way to do this is by synthetic division. So for synthetic division, if you guys don't know how to do it yet, y minus 2, since this is 2, I put this on the outside, and from here, for my numerator, I focus on my coefficients. So these two have a coefficient of 1, so I get 1, but we should also have y squared, y to the power of 3. The second lowest exponent is y squared, but as you see, there is no y squared, so that's going to be a 0. Then the third lowest is just y to the power of 1, which is y, and we have 1, so the coefficient is 1. And then finally, we have negative 10 at the end. So now to do this, I'm going to first drop down 1. 2 times 1 is 2, so I'm going to put 2 here. 0 plus 2 is 2. 2 times 2 is 4. 1 plus 4 is 5. 2 times 5 is 10. Negative 10 plus 10 is 0. So I get a remainder of 0. And I get 1, 2, 5, which will be my coefficients. So I get y squared plus 2y plus 5. Meaning, y to the power of 3 plus y minus 10 divided by y minus 2 is equal to y squared plus 2y plus 5. So now we can say that y minus 2 times y squared plus 2y plus 5 is equal to 0. And now, using this equation, we can find all our solutions to our original equation. So to do this, I get two equations. I get y minus 2 is equal to 0, and y squared plus 2y plus 5 equals 0. So for y minus 2 equals 0, obviously this is easy. I just add 2 on both sides, and I get y equals 2. And this is a solution we already got. Now for y squared plus 2y plus 5 is equal to 0, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is 2, and c is 5. So I get y is equal to negative 2 plus or minus the square root of b squared, which is 2 squared, which is 4, minus 4 times a, which is 1, times c, which is 5, all over 2a, so 2 times 1. And this is equal to negative 2 plus or minus the square root of 4 minus 4 times 5, which is 4 minus 20, which is negative 16, over 2, which is equal to negative 2 plus or minus the square root of 16 times the square root of negative 1 over 2. And the square root of negative 1, if you guys already know, is the same thing as I. So the square root of negative 1 is equal to the imaginary number I. So this is equal to negative 2 plus or minus the square root of 16I over 2. And now the square root of 16 is equal to 4. So I get y is equal to negative 2 plus or minus 4i over 2. And now if I divide this by 2, I get y equals negative 1 plus or minus 2i. So these are two more solutions of y. So I have 3 solutions in total of y, but hold on, we're not done yet, because remember how we let 2 to the power of x equal to y. So 2 to the power of x, well, how can this equal an imaginary number? It can't, meaning this is not a proper solution for y, and my only equation from this is 2 to the power of x is equal to positive 2. And this is easy. All I have to do is rewrite 2 as 2 to the power of 1, and these two exponents equal each other, meaning x is equal to 1. So x is equal to 1 is my solution for this problem. Alright, so in this video, I'm going to be solving the problem 7 to the power of 100 minus 7 to the power of 97. So for my solution, I'm going to rewrite my problem right here. And the first thing I'm going to do is I'm going to rewrite 100 as 97 plus 3. So I get 7 to the power of 97 plus 3 minus 7 to the power of 97. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 7 to the power of 97 plus 3 is going to equal 7 to the power of 97 times 7 to the power of 3. And I have this minus 7 to the power of 97. Now from here, notice how both of my terms have 7 to the power of 97 in them. So I can simply factor out 7 to the power of 97, and I get 7 to the power of 97 times 7 to the power of 3 minus 1. And 7 to the power of 3 minus 1 is, well, 7 to the power of 3 is 343. So I get 343 minus 1, which is equal to 342. So I get 7 to the power of 97 times 342. So this is my answer in simplest form.